I welcome you all to Computer Architecture and Organization course. Now let's begin with the evolution of computers. Now the first question comes to mind, what is a computer? Computer is a machine that computes or calculates. What does it calculate? It calculates or operates or performs arithmetic operations with the basic foundation for arithmetic operations. Now let's proceed with the evolution of computers. Calculating machines capable of performing the elementary operations of arithmetic, addition, subtraction, multiplication, and division. These are called what is the elementary computers. The basic computers which can perform the elementary operations for arithmetic. And it was discovered or used in 16th century or built in 16th century, and then it evolved. Now we know that when a machine or a process is being researched in a country, it is not only confined to that country alone, and now the evolution is just beginning. The French philosopher Blaise Pascal of 16th century invented an early and influential mechanical calculator that could add and subtract decimal numbers. Now, in the first computer or calculator machine, it was able to perform only simple elementary operations, and the numbers that we used here were integers. That is, we did not have any decimal points and etc. But in case of Blaise Pascal's influential mechanical calculator, we could do that. Now the next step is occurring. Now in the next step, in Germany, Gottfried Leibniz extended Pascal's design, the previous design, so that it could perform multiplication and division. It was only in the Gottfried computer that we would be able to perform multiplication and division. Previously, it was only addition and subtraction. Now, the real race begins here. The mechanical device computing devices, such as these, remained academic curiosities until the 19th century. That is where, that is when the commercial production of mechanical calculators begin. And this is very interesting because until then they did not produce commercially the calculators or computing devices, and therefore really they had no actual interest in developing them. And now the evolution is just starting, and now we will see the real attempt here. Here we can see the various attempts to build general purpose programmable computers, etc. from the mechanical devices used in calculators. Nowadays, we see the electronic computer or electronic calculator, but previously it was purely mechanical. It was governed by physics and other concepts, and it was very slow compared to today's electronic computing techniques. This topic, Babbage's difference engine, is very important for you. Is very important for you for your quiz and other exams. You have to mention a short note of Babbage's difference engine. Now let's delve deeper. In the 19th century, Charles Babbage, to us, he was the father of computer, designed the first computers to perform multi-step operations automatically. Now we are seeing the evolution, dramatic evolution from here on. Designed the first computer to perform multi-step operations automatically. This thing I repeat because it signifies the evolution, the difference between the previous one and this difference engine or this computer, that is without human intervening in every step. We are familiar with some supervision and unsupervised works. So this is it. The first ever computer that performs multi-step operations automatically. Again, the process were entirely mechanical. The process worked like this. It was intended to compute and print mathematical tables automatically, thereby avoiding many errors occurring in tables that are computed and typeset by hand. What it was doing here is that while we were using our hand or our mind to calculate and paper to write down the calculations, it might contain some errors. However, it was absent in these mechanical computers because its operations were automatic, free of human error. However, the main drawback was that only one arithmetic operation could be performed automatically, and it was addition. While the method of finite differences embodied alive in the difference engine can calculate many complex and useful functions by means of addition. That is, we have used. We know about how to calculate with two's complement or one's complement, and how can we subtract a number by using two's complement. It could be done. It was used. This procedure was used in this difference engine. So let me recap. The Babbage difference engine was the first computers to perform multi-step operations automatically, and then it was only possible to use one arithmetic operation, addition, but we could calculate the differences or subtraction using 2's complement or other methods. And then the next evolution occurred. Babbage's difference engine. Here we see it was a demonstration prototype, and later he improved his design to difference engine number 2, which was to handle seventh order polynomials and have 31 decimal digits for accuracy. And here the improvement was it was able to handle seventh order polynomials and had 31 decimal digits for accuracy. It was purely a theoretical engine which was later constructed by, here you can see difference engine, where it was constructed by the Science Museum of London, and it took total 17 years. You can see this video on YouTube. So let's get back to the lecture. Now this improvement is the foundation that was used later to build today's electronic computer. The decimal digits of accuracy pioneered it. Let's proceed further. The analytical engine, the actual mechanical computer. Here, this line is very important. Here it is mentioned that this machine is considered to be the first general purpose programmable computer ever designed. This is the first mechanical computer that was used for further calculations, and it was called Analytical Engine. The difference engine was conceived of much more powerful computing machine, and this analytical engine could not be built at that time, so it was only theoretical concept at that time. Now is the structure for Babbage's analytical engine. It had program control unit, PCU, which stored operations and variables, and the memory was called the store, and the arithmetic logic unit, which performed the arithmetical calculations, arithmetic operations. It was in otherwise called the mill, and it was also used to have a part input output equipment, printer and card punch. And let me add an arrow here. to get input from the user and to send the output. It needs to have be both ways, like a full duplex system. The process here is when we start to give input, it goes to the main memory, and the variable cards and data exchange occurs between main memory and the arithmetic logic units using the operation cards. We have completed the assembly language programming or assembly language course, and we know how the operation works in the assembly language, and it's the basics. It got it basics from this analytical engine or analysis. And when it does return the this structure calculated and returns the output in the printer. It is how it works, the structure. So let's proceed further. These are the descriptions of the analytical engine that I have already told you about. So read it by yourself. If you have any problem, you must ask me. Please do not question what is Jacquard loom. It's what do we know as a simple loom. Google it and you will get a good picture, and then you will laugh about it. So the program for the analytical engine was composed of two sequences of punch cards, operation cards to select the operation to be performed by the mill, and the available cards to specify the locations in the store from which inputs were to be taken or results sent. Operation cards is used to hold the operations that we needed to perform. The sequence was predetermined to perform an operation, and the variable cards was used to store the values for operating on them. And it's as simple as that. Now let's proceed further. Now the starting for the electronic computer has begun. First, we need to know why we needed electronic computer. Because of the drawbacks of mechanical computer, we needed another improvement so that these drawbacks could be removed. Now, in electronic computer, these drawbacks were removed. The computing speed of the mechanical computer was very slow, and the transmission of the digital information was quite unreliable. The reason behind this is that while the mechanical computer had no error of its own. It was very slow, and because of that, the information that was transmitted was was unreliable. So these two are the drawbacks. Speed is limited, and digital information transmission is unreliable. So if you are asked what are the drawbacks of mechanical computer, you give these 2 points and it would be all. If you are asked why did we needed electronic computer, the answer is the same one, because because of the drawbacks of the mechanical computer, we needed the electronic computer. Now let's move on to the electronic computer. The first thing that we notice in electronic computer is the electron that we use to transmit at a very high speed, that is the speed of light, 300,000 kilometers per second. Electronic devices such as vacuum tube of electronic value, which was developed in the early 1900s, permit the process of and storage of digital signals at speed far exceeding those of any mechanical device. This is true for every electronic computer. Because we learn to harness the power of electrons, we gained two important things: transmission reliability and speed. Processing and storage of digital signal at speed, and the other thing was reliability. These two things makes it a better computer than the mechanical one. So for example, if you are asked to give the difference between electronic computer and mechanical computer, you need to focus on reliability and speed. That would be all. In the next class, we will start with the evolutions, the generations of computer. Take a look at your slides, and thank you for listening to this lecture. Hopefully, we will do fine in our quiz. Thank you all.